Hi, thank you, Tanisha. Thank you for having me here. The topic for my talk today is how we integrated React Native into existing native Swiggy apps. So, Swiggy has its existing Android and iOS apps live on App Store and Play Store. This is about last year when we started experimenting with React Native, and we wanted to see if we could power some small content in the native Swiggy apps through React Native. I'll start by introducing myself. My name is Jasbir. I'm working as a software engineer in Swiggy in the Diners team. Diners is a new business line that is coming up inside Swiggy. So, we have a lot of different business lines like Instamart, Genie, stores. These are different business lines that we have. Diners is one of the newer offerings of Swiggy where you get sort of perks and discounts when you're dining out at a restaurant. Yeah, and these are my LinkedIn and GitHub handles. You could reach out to me and we can talk. I'll start by talking about why we chose React Native to build a new business line within Swiggy. So the new business line that I'm talking about is Diners, which I was talking about earlier, which is the team that I'm from. The first reason why we chose React Native is native interaction and capability. When it comes to native, the performance that you see of a native app is always much better compared to, let's say, a WebView or any other cross-platform solution. There are actually very sound reasons for it. Basically, a native app is built differently. It is built to interact directly with the OS and the hardware of the system. So let's talk about web views. So in case of web views, you don't get all the capabilities that a native app has. For example, if you had to interact with Bluetooth or let's say Wi-Fi hotspot or even camera of the device. So these are places where native apps have an edge, and we wanted to leverage that edge, obviously. And the second reason why we chose React Native is speed of development. We wanted to have this business line out as fast as possible, and we wanted it out for both the platforms, Android and iOS. So React Native lets you do that. Lets you write common code. 99% of the code that we wrote is common, except for that 1%, which was some conditional platform specific code. And regarding speed of development, like there's one more issue that I faced while working with native apps. So when you're working on Android Studio or Xcode, especially if your project is large, right? So even if you change a small string in your project, you would have to rerun the project, and it will take anywhere between 10 to 15, 20 minutes, depending on the size of a project. So this is a problem when it comes to coding, and React Native comes with, as we all know, hot reloading or live reloading. So that helps you speed up the developer experience greatly. And finally, the ability to be able to send on-fly updates. So native apps go through their own tedious process of releases on App Store and Play Store. They get reviewed, and then finally they are released. And again, it's up to the user whether they want to update it or not. So with React Native, using code push, you can achieve a lot of different sort of update methods in which you can have the newer bundle downloaded in the background, and then once the user opens it again, you'll be able to see the newer bundle. Or you can have the user choose whether they want to update the bundle or not. So all those capabilities are there while still being able to send updates on fly. So you don't need to rely on App Store or Play Store uh, updates. So I'll first talk about what we were trying to accomplish with this. We have an existing native Android app, which is written in Java and Kotlin. And then we have a existing iOS app, which is written in Swift and Ruby. And what we wanted to do is to have some React Native powered content, which would work on both these platforms. This is standard, like this is what React Native does essentially. So the only difference here is that we had existing projects, Android and iOS projects. In order to solve this, we came up with our first initial sort of naive approach where we had a parent React Native project, and Android and iOS were sort of sub projects or sub folders within this parent project. So the folder structure would look something like this. You have a React Native project, you have an index.js, you have SRC where most of your code lies. And then you will see in green and blue these Android and iOS projects, which are sort of subfolders within the parent project. And then there's this package.json. Package.json will generate node modules. and everything, all the packages, sort of React itself lies inside this node modules. So basically, React is a lot of things, and one of those things is that it's a native library in itself, which helps you render native content using a JavaScript bundle. That is what React is in a nutshell, sort of. So in order to get those React dependencies, which are Gradle dependencies or pod dependencies, you need to specify a path where it needs to look for those dependencies, which is node module. So inside your settings.gradle or your pod file, you will find something like a dot dot slash node modules, which will sort of reach out to the parent level node modules and pick up dependencies from there. So I'm not sure if you are able to see it, but we started with this approach and we faced a lot of challenges with this approach, which I'll cover here. So the first challenge we faced was close coupling between React Native and Native, of course, because native projects, Android and iOS, are subfolders within the React Native project. So we did not want this. We wanted to have a decoupled system where native doesn't need to care about what React Native is doing, and React Native doesn't have to care about what native is doing. And another problem that we had is the build time would increase. We already had native existing apps and they already had large build times. So we do not want to add on to this build time. So this build time is essentially the time that it would take for the React Native CLI to generate basically the bundles, Android and iOS bundles. So depending on your project size, this adds around 2 to 3 minutes to your existing build script, which was a lot for us. We actually wanted to cut it down, not increase it. And finally, it gets difficult to maintain. Like there is this large project, and it gets difficult when you're trying to manage releases. Like let's say you want to send a pure native release, or you want to send just an Android release or just an iOS release, or probably just a React Native release. So managing those releases inside this single large repository, and like moreover, there was no solid reason for us to combine all these projects into one project, because these are already independently functioning projects. We did not see any reason why we should be combining them. And yeah, finally, this is sort of the biggest reason why we did not like this method, because it would impact our existing native teams. Like they would have to change how they work. Instead of cloning the native Android or iOS repo, they now would have to clone sort of the parent React Native folder and then work on top of it. And they might also require some knowledge, like people who are working with React Native, they'll know that there are some linking issues or library issues, which the native team doesn't frankly need to care about. So these were sort of the reasons why we did not like the initial approach. So once having identified what was wrong with our initial approach, we wanted to know that identify what we exactly want out of this current setup that we are talking about. So one is that we wanted to be decoupled from native, that is for sure. Like Android and iOS projects should not be subfolders, definitely. And it should be easy to send updates. It shouldn't be a painful process. Then it should not impact the build time. Like the build time should remain intact. And finally, it does not impact the existing native teams who are actually working on it already. So before jumping to the solution that we came up with, I'd like to slightly talk about how React Native integrates with native Android and what goes on sort of behind the scenes. So there are in total 4 major steps, like when you're trying to set up React Native inside an existing Android project. So firstly is the setup. You need to add React Native Gradle dependency inside your settings.gradle and app/build.gradle, and that will make your com.facebook.react, which is basically the React Native Android library, accessible within your project. So this will now be able to power content using React Native. Next is AutoLinking. Like we have a lot of different native packages like React Native Camera, React Native Web View. All these are sort of have native dependencies. So these, when I'm talking about native dependencies, these are basically Objective-C or Swift or Java or Kotlin files, which are present inside node modules. So these are essentially just files right now, which are present inside Node. They need to be linked inside the Android project so that it is usable by Android or iOS. So that is what AutoLinking does in React Native. There is a script inside the React Native community package, which I'll be talking about in detail next. So this is native modules.gradle, which automatically links all those packages and lets you sort of use those packages. And next is the build step, where in the Gradle there's a script which would trigger your React Native CLI to generate the Android bundle, which is the index.android bundle, which has all the JavaScript code. And then finally, this generated bundle needs to be copied into the project, so it is getting bundled with the APK file when it is going to the Play Store. So in this case, what happens is that there's this React root view, which actually comes from the React Native package. And this React Native root view will be able to sort of run the generated bundle and render native views using this bundle. So this is sort of in a nutshell how React Native works inside Android. It's very similar to how it works in iOS. So in the setup again, like there's this pod dependency that you need to add. Using that, like the React pod will now be accessible. And for auto linking, there's again a counterpart which is native modules.ruby script, which is again present in the React Native community package. This takes care of the auto linking like it does for Android. And again, you need to generate the bundle, but it's a separate bundle. It's an iOS bundle. So it's index.ios.js, which is generated using bundle iOS command. So this is again triggered automatically by React Native. And finally is the copying of this bundle, which gets sort of bundled with the IPA file. And finally, RCT root view will be able to run React Native using this bundle. Okay, so I was talking about auto linking earlier. So wanted to discuss how auto linking essentially works. So I talked about it little briefly earlier. So basically, what auto linking does is all these Java or Kotlin or Swift files, which are essentially packages, get copied and then linked into your current target of the app, so that they are sort of usable Gradle and pod dependencies. So native app can sort of use them. You can read more about it here. Like I've put up link here. So the script that I was talking about earlier. So if you go inside the source code of React Native, right? So inside React Native community, you will find this script. This is essentially the script that takes care of the auto linking part of it. So I wouldn't like get into the code of how this works, but you can go through it. I will just explain what it does in a nutshell. It will loop through all the dependencies that you have defined, pick up the ones that are defined as iOS or macOS dependencies, and then it will sort of copy them and attach them to your current target. That's it. It's not very fancy. There are a lot of other things going on. You can check out the file, but in a nutshell, this is what is happening. So this, like, you don't need to link packages manually. This is a very recent update in React Native which helps you do that. So this is a very useful feature. And similarly, there's this counterpart Gradle script, which is present again inside React Native community package. You can find it inside the CLI platform Android folder. So why I'm talking about all of this is that when we were coming up with our implementation, we actually went through all of this and we wanted to understand how actually React Native renders native content, and how all of these things that we sort of just use, how do they work actually. So yeah, this is the script which takes care of it in Android. And finally, like I'll come to our architecture, what we did. So instead of having this parent React Native project and having sub modules inside it, we built a standalone React Native project. And from inside that, we deleted the Android and iOS folders. And what we did is, like, whenever there is a merge that happens to the sort of master branch, there's a CI job, like continuous integration pipeline, that gets triggered. And it does a couple of things. Like the first thing it does is it runs checks and runs the test cases, make sure everything is fine. And once it does that, it will finally generate the bundles itself on a remote job. So these will be the Android and iOS bundles, which it has now, and it will finally publish them as a separate NPM package. So this is a private package that we will use later. So the contents of the package you can check out here, like the third image. So basically, there's this package. It has a build folder. Inside it, you will find Android and iOS folders, and both will have the bundles and also the assets. Assets are essentially the icons or images, MP3 files, whatever you might have used. The interesting thing here is the package.json, which you see in the end. So this package.json is a package.json separate from the package.json of the React Native project. So this package.json will contain only the native dependencies which are required by native. So it won't contain any of the JavaScript dependencies. For example, Apollo client doesn't end up here, but React Native video will end up here because it has native dependency. So by the end of it, we have a published npm package, and there's no extra build step required because the bundles are already built. So the next step that we do is we now go into the native projects. We create a package JSON there, and this package JSON is just essentially has just one. We might have, yeah, it would look something like this, like just one entry into the package JSON, which is our custom RN. This is a private package on npm that we have published. So we have this package JSON that would generate the node modules. So what the node modules will contain is essentially what I was talking about in this slide. It will have the bundles already present. And from the package JSON, all the React Native sort of library dependencies are already downloaded. So there's just one extra step that we needed to do, which was copying this bundle and linking it to the current app. And after that, like, the everything is sort of done. The existing app can have go through the existing build pipelines, and whatever steps were there, it can continue. The bundle is already linked, so you don't need to care about anything. So we already had existing native apps, and the reason we are integrating React Native into it is sort of we wanted to reuse some of the features that native already has. So for example, the first thing would be fonts. Like we do not want to add fonts, obviously. In our own project, we did not want to add on to the size of the app, so that's why we reused existing fonts. And then screens also we reuse, like for example, payments was entirely reused because that's an existing feature that Swiggy already has. So all we did is we wrote some bridge functions that would just navigate to those pages, and those pages already have whatever functionality is required. So you could sort of seamlessly transition between native to React Native, and then React Native again to native, and nobody would get to know sort of which part of it is native and which part of it is React Native, except for us, of course. Like, we know which parts are native. And finally, the headers, like we have some network clients and network interceptors, some security features which are already built into the native app. So we did not want to sort of reinvent the wheel. We reused all these three components. There were some more, like broadly these three components which we reused from the native app. Okay, so let's jump back to our checklist that I was discussing earlier, and see how our current solution implements all these three things. So the first problem that we had was close coupling between native and React Native. So we have sort of destroyed that because we now have a standalone React Native project. It doesn't need to care about what native is doing. Native doesn't need to care about what React Native is doing. So it's totally decoupled. There's just a package that is published, and native repo is going to use that package. There is no impact on build times. Why? Because the bundles are already built. So the native app, during the build step, it just needs to, the bundles are already present inside node modules. It just needs to sort of pick up those bundles and then attach it to the current app. That's it. And there is no impact on existing native teams because they will work as usual. We have just added one package JSON and some integration code that we've added into the native repo. So for them, it's just a small PR that went into their project, and they will continue to work how they were doing earlier. And finally, it is very easy to send updates now. Like, every time we need to send an update, all we need to do is publish that package and then update that package version inside the native package JSON. That's it. And the next app release, whenever it goes out, it will have our latest published bundle. So like this, we have accomplished almost everything that we were looking for. However, that does not mean that it is the perfect solution. There are two future scopes that we have identified, which are sort of what we are looking to do in the future. So one of them is we have created a package JSON inside native Android and iOS projects, and we also create node modules. So this doesn't necessarily have to work that way. So all we need is sort of native library files, and then the bundles. So they could be all bundled together and published as a jar file or as a separate pod spec project for iOS. And that could go as one single line of dependency inside your settings.gradle or your pod file. So that would clean up our current setup greatly. So this is something that we are looking to do. And the next scope that we are looking to solve is slightly more complicated, where as like you all must be aware, React Native doesn't support chunking of bundles as the web does. So we want to support multiple business lines in Swiggy, use which will be powered by React Native. So let's say there's a business line A and then there's a business line B. So both A and B could be using some common parts of code, but essentially right now both A and B are present in the same bundle. So every time A or B is opened, the whole bundle gets downloaded. So what we are looking for is implementing sort of a custom code push solution where there could be a bundle for A, there could be a bundle for B, and then there could be a common bundle. So whenever user opens a business line, the bundle that is downloaded is A and then the common, and we sort of do a plus common by ourselves. So this would like greatly improve the performance of the app and also the developer experience. Yeah, and that sort of wraps up everything that I had. I hope this was informative. I'll be happy to take questions. I wrapped it up quickly. I did not want to eat into the lunchtime. Thank you.